Alright, so welcome to a very new class, and in this class we will be considering a very important topic, and that is surds. We'll be considering surds. So what is surds? Can you think about it? Try to think, what is surd? Okay, so let's write this down. Surds are simply irrational. Note the word irrational. Surds are simply irrational numbers, okay, that are expressed as roots. This root can be either square root, it could be cube root, foot root, etc., but cannot be simplified into exact decimal or fractions. All right. Now, when we take some examples, we will understand what we are talking about. Okay, this is square root of 3, and this is square root of 5. Okay. Alright, and also this is square root of 4. Okay. So, we say, for example, these are surds. This is square root as well. Yeah, let's have it well. This is square root as well. So say, for example, the square root of 2, the square root of 3, the square root of 5, square root of 7, square root of 11, square root of 13, and the rest are surds. Why? Because there are irrational numbers that, if at all we are looking for their square roots or cube roots, they cannot be simplified into exact decimal or fraction. Yeah, they cannot. Like, they are not, you can't have their answer, exact answer. But if you look at the square root of 4, we say that square root of 4 is not a surd because it simplifies readily or neatly to 2. Looking for square root of 4 is 2. And other forms of numbers that are not surd, like for example, the square root of 9. Square root of 9 is not a surd because square root of 9, we know square root of 9 to be what? To be 3, right? Square root of 9 is 3. And which other square roots of it do we have again? Okay, for example, square root of 16. Square root of 16 is not a surd because we can simplify it neatly. We can have the exact answer. Square root of 16 is 4. Alright, is 4. So surds are simply rational numbers that are expressed as roots. Like this root can be square root, can be cube root, etc., but cannot be simplified into exact decimal or fraction. Alright, there's something I want you to understand, and this is a very powerful intuition I want you to understand. Now, for you to understand, so think of surd as a way to preserve precision, accuracy. That's it. When you calculate for the square root, this is square root. When you calculate for the square root of 2, you sometimes, instead of approximating it as 1.414, you are keeping your answers exact. You understand? And the approximation can lead to errors, especially in exams or in practical applications. Surds, on the other hand, maintain mathematical integrity. All what this story means is surds helps us to maintain precision. It helps us to maintain precision, and also it helps us to have mathematical integrity. So rather than for us to have the square root of a number that is not a perfect square in the decimal form, or approximating it, not just in decimal form, approximating it, it helps us to have it in a very precise, to have a precise answer, and helping us to have integrity. Okay, let's proceed by seeing types of surds. There are different types of surds. We're going to look at the 3 types that we have. We have the first one here as a simple surds. We have the second one here as the compound sorts, and we have the third one here as the mixed sorts. The simple sorts are just those sorts that just have the rational roots. These are single rational roots, just single rational roots, whereas the compound sorts involve addition or subtraction of two or more sorts. Yeah, anytime you have to do with addition, subtraction, can even be multiplication, can even be a division of two or more sorts, that become a compound sort, whereas a mixed sort contains both rational and irrational parts. Yes, but the rational and the irrational part, just as the name implies, mixed sorts. So three types of sorts: simple sorts, compound sorts, and mixed sorts. Okay, so let's look at the rules of that govern sorts. Let's look at it. Okay, before we look at the rules that govern sorts, we look at the properties of sorts. Let's take properties of sorts. Alright, so the first property we're going to look at, the first properties of sort we're going to look at is what is called the multiplication of sorts. Yeah, the multiplication of sorts, that's the first one we're going to look at. And what do we mean when we say multiplication of sorts? Let's look at that property. What happens? Okay, for instance, if we have square root of a, and then we multiply with the square root of b. Now we are going to have what we call, square root of ab. That's for the multiplication of sort, we're going to have square root of ab. Okay, now for example, let's have ag here. Now we can have something like square root of 2 times square root of 3, then square root of 3, and if we can multiply this out, because in multiplication you just multiply everything out, just it can multiply itself. Two sorts can multiply itself. That will be square root of 6. So that's for the multiplication of sorts. Okay,